All right, so a couple minutes past the hour here, so I guess I'll get started kind of with the intro, and a few more people may roll in as we're getting to the content. So yeah, thanks everyone for joining the quarterly call focused on transcoders and infrastructure operators. We try and keep this one really focused on useful, practical tips and Q&A and troubleshooting for those running infrastructure on the LivePeer network. We're recording it. We're live streaming it to livepeer.com/TV, so know that if you're participating, you may be recorded. I think, let's see, I prepared kind of just a minor overview slide just to share the agenda here. I think on today's call, what we want to do is focus mostly on competing for fees on the LivePeer network. And as we're kind of testing, pushing a bunch of streams through the network, nodes are starting to earn fees. Some nodes on the network are not necessarily earning any fees yet. They've had a bunch of questions as to why, what they can do to kind of get under the hood and understand why they're not kind of competing and winning work. So we're going to give some practical tips on how to test and validate your setup, talk about some low-hanging fruit in terms of making sure you're priced correctly, how to understand what prices are being paid. Talk about after you've actually won a job on the network, how to retain that work and not just lose it, because you need to continuously kind of perform well to earn enough tickets to actually have a chance of winning one and cashing in a payment. And then since some of the output of this is to actually compete and cost effectively, you probably need a GPU setup. We could talk practically about how you validate and test the GPU setup or partnership before you make a big investment in a lot of hardware on the network. And of course, plenty of time for Q&A as well. And as always, this is like for the community, it's for you. It's not for us to make a big presentation. So please jump in, interrupt us, raise any questions as they come up, and we can go wherever this call takes us. Cool. So yeah, anyone feel free to jump in before we start if you want. Otherwise, I'm going to hand it over to excuse me, Eric and Adam, who prepared a little presentation on fees and troubleshooting.
Awesome. Thanks, Doug. Yeah, so we prepared just a quick presentation. We're going to go over, we've been working with some of you troubleshooting, and we've seen some like kind of common questions and frequently asked questions. So we're just going to go over some of the questions we've seen, and then give our recommendations so that you're best positioned to win work on the network. So Eric, you want to bring up the slides?
Right. Give me 1 second.
Sure.
All right. I will present.
Awesome.
Yeah. You guys see this?
Right. Great. Yeah, so like I mentioned, we're just going to share some of those frequently asked questions, go over our recommendations, and then leave some time for Q&A.
Adam, I think we lost your audio. We're just hearing static now.
Can you hear me now?
Yeah.
Okay, sorry about that. Great, so yeah, do you mind skipping over to slide 4?
Yep.
Cool. So I think by far and large, the number one question we've seen is Why am I not receiving any fees? So we're going to cover that. Another question we've seen is, where can I view my redeemed winning tickets per round? It can be good to know the frequency by which you're winning work. Number three, another common question, how much should I charge per pixel? Per pixel pricing is, I think, a new concept for a lot of us. So it's not immediately intuitive how much you should charge per pixel. We'll go over that. Number four, how can I optimize my ROI? So, based on how much stake I have, how many GPUs should I invest in, stuff like that. Another common question is, where can I find what other registered orchestrators are charging so that I can optimize my price setting? This is a competitive marketplace, and it's good to know, on the supply side, what others are charging. It's also good to know what broadcasters want to be paying for. So, like, where can I find this information? Another question. When can I expect to start seeing more video being streamed into the network? So it's a fair question. You're investing time and money and setup. You want to have a good idea or understanding when video might be start flowing into the network. And then finally, how are orchestrators picked right now? How does the orchestrator selection algorithm work? So Jan's gonna talk briefly about that as well. Cool. So we're gonna just go over these questions one by one and give some of our recommendations. So Eric, you want to skip over to slide 6?
Yeah.
And feel free to, by the way, anyone can feel free to interrupt with questions as I go through these. So yeah, why am I not receiving any fees? What we found, it's most likely one of 3 reasons. So number one, make sure you're not setting your price per pixel too high. So broadcasters can set a max price they're willing to pay. And if your price per pixel is too high, you're not going to be eligible for that work. So right off the bat, make sure your price per pixel is not set too high. That could be the reason. Number 2, don't make sure your price per pixel is not set too low. It could be that you are in fact doing the work, transcoding video, but you're just not getting paid for it because you're charging like 1 way per pixel. And then number 3, make sure you're transcoding in sub-real time. So sub-real time, what that means is you're transcoding, the time it takes you to transcode a video segment is less than the length of the actual video segment itself. So this is desirable because you want to make sure you're not adding any latency to a live stream. And the selection algorithm will favor those that are transcoding in sub-real time. So how can you test this? How can you make sure that you're in fact transcoding in sub-real time? You can set up your own broadcasting node into your transcoding setup, and just make sure you turn on logging to a verbose level so you can see what you're if you're in fact transcoding in sub-real time. So Eric's going to do a really quick demo and show you how you can do this.
All right, so let me stop presenting and start presenting my whole screen.
And while Eric's setting up the demo, Victor asked if you'd be willing to share the link to the slides so people could take a look as well. So you maybe paste it into the chat if it's public.
Yeah, so let me see. Can I make this public? With the link. Okay. All right. So let me share this link. So everyone should be able to see the link. So what I'm going to share is a way for you to debug for yourself whether your orchestrator is set up to process video and to be able to see the processing time in your orchestrator, so you can more effectively debug and make sure that you have the right system set up. And the way I'm going to do it is, since I already have an orchestrator running on chain, I'm going to use the live peer community node as an example, because it's one of the orchestrators on the network right now, and it does transcoding. So I'm going to set up a broadcaster. I'm going to send a little bit of ETH into that broadcaster, and I'm going to tell that broadcaster to only send video to the orchestrator that I'm running. In this case, the live peer community node, and we should be able to see the log statements that are in that on that orchestrator. We should be able to see the processing time. So the first thing that I did is that I just started a Google Compute instance, and I have downloaded the live peer node onto that instance, and I have installed FFmpeg. FFmpeg is a video streaming tool that's used to stream any kind of video into the live peer node. So what I'm going to do is I'm going to run this live peer node on chain as broadcaster. So let me make this a little bigger. Network, mainnet, and now I've started a broadcaster node on the main network, right? So I can see it's taking a little bit of time to kind of load all the information on chain. Right now, this usually takes a little bit of time because it's going through the whole orchestrator set, and it's trying to ping each of them. And there's a timeout associated with it because a lot of the orchestrators on chain right now aren't set up correctly. So you see a lot of timeouts happen. But now we have the broadcaster up and running, and I can see if I run the CLI, I am connected to my broadcaster. And right now the broadcaster doesn't, it has no ETH balance, it has nothing, right? So what I'm going to do is I'm going to list out all the registered orchestrators. And the reason I do that is because that presents a good view for me to see the service URL for each of the orchestrator. So right now it's loading from on-chain all the information, and give us 1 second. Should be able to see that information. Maybe as it's loading, what I can do is I can send a little bit of ETH into this node. So what I'm going to do is to go there, send a little bit of ETH. So let's say I'm going to do 0.1 ETH. Hopefully the network is not too congested at the moment. So now we see that we have this list of orchestrators on chain listed. I know that my orchestrator is this one, and therefore, therefore I know that I can go here and look at the service address. And now with that information, I can start I can restart my broadcaster with the orchestrator address statement. And when I specify this, I'm telling the broadcaster to only connect to that specific orchestrator and no other orchestrator. So now I am connected. If I stream video into this node, I should be connected to that orchestrator. So let me, what I can do now is I can download a video from online.
So while Eric's doing the video setup, anyone have any questions so far about what he just did in terms of preparing a broadcaster in order to send video to only his specific orchestrator?
All right, so I'm copying this address. This is just the MP4 file. I'm downloading it onto my GCP instance. Now I have it. So what I can do is I can use this command to stream the video into my node. And my node is at RTMP localhost 1935. Oh, at least one output file. What's going on here? Let me see. At least one output file must be specified. Oh, maybe what I need to do is this. Let me try something. Interesting. Oh yeah, I forgot an argument. Here we go. And now it's streaming the video. I can see it's coming through. And I can see, interestingly, there's actually no orchestrator found. So there's no transcoding happening, right? So my orchestrator, the orchestrator that I have specified is currently not online and not transcoding. So now I can go in and try to figure out, why that's the case. Maybe I go back here and I try to look at whether I've copied the right thing. Maybe I didn't copy the right thing. Or I can go into my orchestrator right here to see whether my service URL is set up correctly.
Eric, did you put a deposit into your broadcaster and set your payment parameters?
Let me see if I did that. I should have. So if I don't set the payment params, oh, I see, the ETH hasn't gone through yet. That's why. It could be because the network is a little congested at the moment. Yeah. So we see that the ETH that I was sending in still not being sent through. So let me try to up the gas a little bit. Here, speed up. Oh, now I'm sending 2 transactions. Interesting. Oh, okay. So I see that transaction has gone through. Now I go back to here, restart my stream.
You still have to make a deposit, right? You put ETH on the account, you have to deposit it.
You're right. Okay, so what I need to do is I need to come here and make a deposit for the broadcaster. So let's say my deposit amount is actually let's see, I don't have 1 ETH. Okay, great. So let me make a deposit. And the amount in ETH could be 0.0045. 0.0045 because I have 0.01 ETH. Interesting, it's not going through. Why is that? 0.01. Let me try this 0.004. Okay. Maybe I needed to pay a little more gas. So as we see right here, it's making the deposit. We can take a look at the hash to make sure that it's going through. So, loading Etherscan. Today, there's some movement in the crypto market. Could be that's jamming up the network a little bit. But the good thing is that these are all asynchronous steps that people can take before or after the stream starts and finish. So it doesn't really affect any of the streaming experience on LivePeer. Maybe we can skip ahead for now, and then as we get through some of these congestion related things, I can come back and just show people the stream running and show the log messages.
Sure. Yeah, it sounds good. Thanks, Eric. We can move ahead then.
Yeah.
I think we were on like slide 6. Why not bring that back up?
Yeah.
Awesome. So assuming you do, the deposit goes through and you start broadcasting into your own transcoder, you'll start seeing logs. So if you go to slide 7, that look like this, and you can see highlighted in red, one of the logs shows you the actual time it took to transcode a segment. So if the time is less than the segment length itself, then you should be good. Cool.
And by default, segment lengths are 2 seconds. So you're looking for a value there that says took. And in this case, it says 956 milliseconds, but you'd want it to say something less than 2 seconds.
Right.
Might I add that the default transcoding options for the broadcaster don't include 720p rendition, so that you might want to add that to like get the most comparable results to what we're sending into mainnet.
Right. That's because, yeah, if you don't have a 720p output and you just have some lightweight outputs, it's possible you'll see, really fast response times. But if a customer comes or user of the network comes in and wants, higher resolution outputs like 720p, it may take a little longer. And so you want to be sure your node can keep up with that as well.
Cool. Thanks, guys. Okay. Any questions with regards to why you might not be receiving any fees? Okay.
I think, Adam, you did share that you have to make sure that you're priced high enough to receive the fees, but low enough such that you are able to win the work. A good reference point, I guess, would just be knowing the price that our stream tester is currently offering, so that people know they can price a little below that and they'll have the potential to earn a bunch of these test fees. Nico, is it currently offering 25,000 wave per pixel?
Yeah, that's correct. But of course, we charge a transaction overhead cost for redeeming tickets on chain. So you should actually add 1% to that. So it's actually 25,250.
Okay, but so as long as people price under that number you just said, so if they price at 25,000 or 24,000, they would be eligible to perform jobs from the stream tester that's running.
No, it does have to account for the overhead charged. So it has to be lower or equal to 25,250.
Right.
Okay, cool. I think we can move on to some of the other questions, unless anyone has some more thoughts here.
Hey, Adam Nelson here. Just a quick question. So with all the jobs that have been formed at the moment, are they mostly like test transcodes? And is it fair to sort of say that like the issue right now is like the spread between the bid and the ask is too wide, and that's like why one transcode is winning a lot of the work?
Sorry, there was a weird echo. Can you repeat that?
Sorry, two parts. First is, so of the transcodes that have come through the network, are they mostly test transcodes at the moment?
Yeah, I'd say a lot of the streams that have been coming through into the network are from our live peering test broadcaster, which, like as Doug mentioned, has a max price set to around like 25,000 Wei per pixel. So if you want to be eligible to win that work, good idea to set your price below that threshold.
Right. So if we were to compare it to like cryptocurrency terms, the ask, the difference between the bid and the ask is just too wide right now. And only one person is setting their ask low enough to win the work.
Right. Yep. Exactly.
Let me jump in for a minute there, because I think what you're referring to is if you look at that third orchestrator and the amount of fees they've earned is so much higher than what you've seen on the top couple orchestrators. And I think you're asking, why are they winning so much work? Is that right?
Yeah, that's right.
Yeah, so I think basically what's happening, in my opinion, someone correct me if you have more information or if you're wrong, is that the way the job assignment works is it's kind of probabilistically weighted by the amount of stake you have. So if that node has 10% of the stake on the network, then about 10% of the jobs that come in would go to that node first. And so you would think the top two nodes would have the highest chance of winning work. And in fact, a lot of the streams are choosing those top two nodes, but then those top two nodes are not retaining the work. Maybe they get one segment, but they're not encoding it and returning it fast enough. So the broadcast node will then say, oh, I have to choose another orchestrator. And that third node has a lot of stake. It has a high probability of getting selected at some point, but it is actually doing an effective job of transcoding the streams in sub-real time. So it is retaining the work for those entire streams. And therefore, it's collecting the fees that would otherwise be split, amongst those first three nodes on the network. It's kind of winning all of the work for itself. And part of the reason this call and what people should be doing now is like debugging their own nodes to make sure that they can not only get assigned the jobs, but retain them and perform well enough. So that's what I believe is happening there. If people have looked into it further, feel free to chime in.
Yeah, there's one nuance I'd like to add, is that stake-weighted selection is actually executed on a subset of active orchestrators. And that subset is created from those that respond the fastest to like a ping. So it could be that transcoder 1 or 2 in the orchestrator list might also be just geographically far away from our broadcaster that's sending in test streams into the network.
Interesting point. So yeah, it would be interesting to have some people set up test streams in different locations around the world, if they're willing to spend a little ETH to test, or get in touch with us. We could fund a little ETH to test if you're running nodes in different locations. Might be interesting to see which nodes win work out of Asia or Europe, or in the Southern Hemisphere.
Okay, great. Thanks for that. And just so it sounds like there's a few different things there. Do people bidding on work, do they sort of say the maximum price they're willing to pay? Is that how that works?
Yeah, that's correct. You actually, it's not even the maximum price you're willing to pay. It's the price that you are paying. So when you start your broadcaster node, you set the price that you're paying, and you will pay that. And any node charging less than that, willing to accept less than that, will have the opportunity to win the job.
Well, actually, it's the other way around. You're paying the maximum of what you're setting as a broadcaster, but there's always the chance that you're paying less if the orchestrator you selected has a lower pricing than your maximum. That's how it is currently working, at least.
Okay, great, thanks.
Well, one thing that's interesting is many of these things are not protocol enforced, they're client enforced, right? And the client is trying to create a reliable transcoding experience for a broadcaster. That's what it's prioritizing, is reliability. And how we do that is like an iteration on the client side. So it would be interesting for people to test different strategies to maximize the quality and the reliability, but minimize the cost. So, you could make some client updates via a fork or local configuration, or some updates to the code base that said, we'll actually opt to choose the nodes that are charging the least first, and only use more expensive nodes if the ones are not reliable. But that might create a slow start and not be reliable initially. But it would be an interesting experiment to run. And if you could produce data that showed that a strategy worked really well, that would be valuable to the ecosystem.
Awesome. Thanks for the questions. Cool. Yeah, let's press on slide 8. So yeah, another question we've seen is where can I view my redeemed winning tickets per round? So if you're interested to see the frequency by which you're receiving some of this work, scout.cool has some good visibility into the fee market now. So you can see the amount of winning tickets you received over time. If you'd like to build your own visualizations or reports, you could also use the LivePeer subgraph that this data is all being indexed. So you can check that out at thegraph.com/explorer/LivePeer. That's an example query of how you fetch winning tickets per round and the face value associated with them. Cool. So next slide. I think we pretty much discussed this already, but how much should I charge per pixel? So yeah, you should. This should be based on what you want to accept. So for example, LivePeer Inc., like we mentioned, our test broadcaster has a max price currently set to 25K WEI per pixel. So if you want to be eligible for this work, something to be aware of. You can also check out, there's a probabilistic micropayment calculation script that you can check out at the Read the Docs if you want to do your own sort of calculations on what you should be charging. Cool, next slide. Yeah, generally speaking, how do I optimize my ROI? There was a really awesome financial model that was open sourced by Chris Remus and Gleb Dudka that lets you input a bunch of parameters like your stake and how many GPUs you have and a whole bunch of other parameters and outputs some recommendations on some setup recommendations on and what you can expect to see on your investment. And I also saw a grant proposal come in from Chris that would propose to turn this into like a cool interactive dashboard. So that's exciting. Would love to. I think that'd be hugely valuable to the community. But yeah, I'd recommend people check out this financial model if you really want to sort of strategize on pricing and that sort of thing. Cool. Next slide. Where can I find what other registered transcoders are charging to optimize my price settings? So right now, this information is not very easily accessible. There is a grant proposal for an open source pricing tool. And Nico, I know you're working closely with that project, and you've done some work on Go Live Peer to expose some of this information. So if you have anything you'd like to add here, feel free.
Yeah, so if you upgrade to Go Live Peer 0.5.5, so the latest release, and if you start a broadcaster, you should be able to see the price per pixel each active orchestrator charges when you check the list for all registered orchestrators through the CLI.
Awesome. Cool, good to know. All right.
Nico, is that only available if you start a node in broadcaster mode, or can nodes in orchestrator mode also expose that?
Only the broadcaster node will currently fill up the database with the active orchestrator set. The orchestrator will kind of fill up its database over time as it receives on-chain events, but that data is not available initially, so I would recommend using a broadcaster node for that, which can be started like pretty briefly to just check the endpoint and then be shut down again.
Cool. Okay, nice feature.
Very cool. Okay, next question. When can I expect to start seeing more video being streamed into the network? So yeah, generally speaking, I think when the network is 99.99% reliable, there are currently pilots running tests now, and LivePeer Inc. is working on business development to onboard new customers. But of course, if you know anyone building video apps, definitely point them to LivePeer. And I think we all have a part in sort of expediting the flow of video into the network by just running reliable GPU-based infrastructure with good bandwidth and helping debug and improve the software and adding to worldwide coverage in different regions. Doug, is there anything you'd like to add to this?
No, you nailed it. Of course, everyone in the LivePeer community wants to see huge scale video platforms using this network, and it's on all of us to make sure the network is reliable enough. So certainly, those of us that work on LivePeer full time are doing a lot of the work, but we welcome introductions, contributions, ideas, testing, debugging, BD opportunities, etc. Especially if anyone is doing something bottom up, if you're building a new app or DApp, you know, we'd love to help you integrate live peer if it helps solve your video needs.
Awesome. Thanks, Doug. Cool. And yeah, final question that we've seen amongst within the community is, you know, how does the actual orchestrator selection work? So Yandin provided, if we skip over to slide 13, just a high-level overview of the orchestrator selection algorithm, so you have better context in terms of how it works. Yandin, you want to go over that?
Sure. So I think we already talked a little bit about how the selection process works earlier on in the call. So this will just add a little more color to how the process works in more detail. So at a high level, the first part of selection is that the broadcaster is going to try to create an initial working set of orchestrators. So the idea here is that the broadcaster always wants to have a set of orchestrators that it can use. So if one fails, it has backups that it can fail over to. And this initial working set is constructed based on ping times. So if you have a fast ping time, and you might have a fast ping time because you're more geographically close to the broadcaster, the takeaway here is that fast ping times will give you a better chance to be included in this initial working set. So after the broadcaster establishes a certain number of orchestrators in this working set, then it starts using those orchestrators in its working set in the selection process. So I think the key things here are that the selection process is a mix of stake-weighted selection and latency minimizing selection, as has already been discussed. So each orchestrator in the working set actually gets assigned a latency score. And I've included the basic formula for the latency score here, which is round trip latency divided by segment duration. But the important point about the latency score is that it's a way to compare the relative latencies of orchestrators in your working set. And then generally speaking, the lowest latency score in the working set means that it's the fastest orchestrator in the working set. So the selection algorithm kind of proceeds as follows. If the fastest orchestrator in your working set is sub-real time, then we're just going to pick the fastest orchestrator. If the fastest orchestrator in your working set is not real time, then there's two possible cases. The first case is that we have other orchestrators in the working set to try, meaning that we haven't even sent them a segment yet, and we haven't even given them a chance to win work yet. So if this is the case, we'll do a stake-weighted random selection to determine which orchestrator we should try next. But if there aren't any more orchestrators to try, meaning that we've already used each of the orchestrators in the working set once, we'll just pick the fastest orchestrator, and this is based on latency. And then the last two things to keep in mind here are that if you, as an orchestrator, return an error, you're going to be dropped from this working set, and you won't be reselected. And also, the working set can become too small at a certain point. So you start off with a certain number of orchestrators, and once you fall below a certain threshold in size, you're going to do a refresh and add new orchestrators to the working set. So at a high level, those are like the points to keep in mind of how the selection algorithm works. And in terms of concrete takeaways, I think some of them are fast ping times. So being geographically close or geographically distributed are going to improve your chances of being included in this working set. Stake matters in that it's going to influence your probability of actually having the opportunity to win the work in the first place. So the more stake that you have, it gives you a better chance of being tried first. And then once you're tried, if you're actually performant, then you can continue winning work from there. But the lower stake that you have reduces your chances of having that opportunity in the first place. And from a latency perspective, you really want to be low latency in order to continue holding on to that work after you were tried the first time. And I think there's two components that are important to think about here. The obvious one is transcoding time, right? So this is your hardware configuration. Are you using a CPU versus a GPU? What type of GPU are you using? Generally speaking, your transcoding times are going to be faster when you're using a GPUs. And depending on the type of GPU, you might have a difference in transcoding time there as well. But another component there that might not be as obvious is bandwidth. So if you look at the latency score calculation, the formula says round trip latency. So we're not just considering, the broadcaster doesn't just want to consider how fast you are at transcoding. It cares about how soon it can get a transcoded result from you if you're an orchestrator. So additional steps in this process that can influence that are, how long does it take for me to upload a segment to you? How long does it take for me to download a segment to you? So there are cases where you could have optimal hardware set up such that your transcoding time is really low. But if you have bandwidth issues such that it takes the broadcaster a long time to upload a segment to you, or it takes the broadcaster a long time to download the segment to you, that's going to impact the round trip latency, and that's going to result in a not as great latency score for you. Now, obviously, some of these things might be out of your control. The bandwidth issues might also be on the broadcaster side, but I think it's worthwhile keeping in mind that bandwidth on the orchestrator side does matter because it's going to influence this latency score. So I think those are some of the takeaways that might be useful for some people. Fast ping times, so geographic proximity will help you get included in the working set. Stake is going to help improve your chances of being tried and giving you the opportunity to win work. And then latency is going to be the thing that allows you to hold on to work and to continue receiving work after you've been tried. So yeah, those are like some takeaways that I thought might be useful, but happy to talk about this some more if people have any questions or comments.
Awesome. Thanks, Yandon. That was a great overview. We do have 10 minutes left in the call, so we did set aside some time for Q&A. So if you have any questions about what Yandon just spoke about, or any of the other questions, or anything we didn't cover here, yeah, we'd love to hear about it.
Anyone have any hard information about kind of the necessity or the requirement to be running a GPU setup in order to retain work? Have we seen that a CPU only transcoding is just never sub real time?
I have seen that on a lot of cloud hosted instances. This happens. So for example, like I just got the setup working for the broadcaster, so I can show everyone how that works. But when I'm currently hosting the community node on DigitalOcean, and I'm on a CPU in like high CPU instance, but the CPU transcoding is barely keeping up.
Right. I guess the one comment I have about that is I think it's definitely possible depending on the set of renditions for a CPU, like a highly performant CPU, to do real-time transcoding. It just doesn't leave a lot of margin for error, especially when we start talking about bandwidth and like the upload and download time. So it might be able to do the transcoding below real time, but it doesn't leave a lot of margin for error when it comes to like the upload and download time, which once you add those things in, you might be well above real time in terms of the round trip. So I think it's possible, but doesn't leave a lot of margin of error when it comes to like wanting to do the full round trip in real time.
So Quan was on the call, and you shared in the chat that there's some more stats coming for orchestrators soon. Any previews you want to give us?
Hi, sorry, I was looking for the button to unmute myself. Yeah, we're working on almost pretty much finished, which is a dashboard for Orchestrator to see their staking earnings and plus the fee payouts over time. We are adding a lock for the dashboard. So it's basically the dashboard allows you to see any orchestrator on the network. You just enter the address, so you can see pretty much everything about the orchestrator in terms of how much they make through staking and the fee payouts, and all your delegations over time, the list of unbound bound activities, who are your delegators, how much they're delegating towards you, etc. So we're adding unlock. I don't know if you guys are familiar with unlock. It's basically a access control protocol on the blockchain. So we're adding unlock on top, and hopefully finish this week, and then next week can share with the community. So initially you will just buy a free unlock key to access it. We want to be supportive to other projects in the community, and doing initial testing. We'd love to get feedback from everyone who might be using it. I mean, over time we'll probably charge some money through unlock protocol. So.
Nice. Thanks for sharing, and sorry to put you on the spot there. I would be a paying customer.
Excellent.
Anyone have any questions about what we talked about today, or anything else related to running your orchestrator or transcoder setup?
This might not apply to the whoever's on the call right now, but just from like observing some of the performance of test streams on mainnet thus far, there does seem to be a lot of orchestrators that are registered, active orchestrators right now, that are having connectivity issues. So this is apparent when the broadcaster, as you probably saw in Eric's logs, this is apparent when the broadcaster starts up. A lot of orchestrators are timing out in that initial request in order to like fetch things like pricing information and whatnot. So this might not apply to like people on the call, but general word of advice for orchestrator operators is to double check if they are having connectivity issues. And I think the transcoding setup stuff that Eric was demoing and will be helpful in ensuring that, just because you want to make sure that you're publicly accessible and publicly accessible within a reasonable period of time.
Eric, any grand finale in terms of showing the stream running and the fees being paid?
Yeah, I can show that. 1 second.
All right, then we'll wrap up the call. Have everyone out of here.
All right. So what I have here is a broadcaster that's running, and now the broadcaster has a little bit of deposit and reserve, as we can see here, after the deposit transaction finally went through. So now what we can do is we can start sending the video in using this command that I typed before. And by the way, this is also in the live here documentations page. So when I start streaming this video into my broadcaster, you can see that my broadcaster starts sending this video segment by segment to an orchestrator that I specified earlier, and it's getting the segment back, and it's saying that successfully transcoded the video. And if I go over to the orchestrator, we see that the orchestrator is receiving the video, and we can see that this log line is interesting, right? Sometimes it's taking over 2 seconds. Sometimes it's taking 630. This one's taking 630 milliseconds. This one's taking 1 second. So depending on the complexity of the video itself, depending on the length of the video, the broadcaster aims to create a 2-second video segment, but it's not always accurate. Sometimes it could be a little over, or it could be a little under. So this is how long the video is. This is how long it's taking the transcoder to transcode the actual video. And the other thing to keep in mind is that this is right now using the default setting, which means it's only transcoding the video into 360p and 240p, which it's a pretty low resolution setup. Usually when people do transcoding, they do 720p, 360p, and 240p. And if I did that, I think this transcoder would not be able to keep up with sub-real time. And we'll start to see that some error messages start showing up in my broadcaster here. Anybody have anything to add, Yanden or Nico, about this simple test setup?
Just, I think things that are noteworthy in the broadcaster logs, in addition to the transcoder logs, you can see that the submitting segment, there's a uploaded segment log, and it includes this duration field at the end. So that might just be helpful for people to get a sense of like how, if you're testing your own setup, you can get a sense of how long it's taking to upload that segment to the orchestrator. So in conjunction with the transcoding time that you can see on the orchestrator, you can also get a sense, is there any bandwidth issues between my orchestrator and my broadcaster, depending on where my broadcaster is currently located. So this doesn't necessarily mean that you won't have slow uploads for other broadcasters, but you can at least confirm that, like, given a setup, you get a sense of how long it's taking to upload that segment.
Yeah, that's a good call. Another thing to pay attention to here is this message. It says no sessions available for segment number 91, and this most likely means segment 90 took more than real time, so that for the next segment there's no available sessions for the orchestrator for the video to be transcoded, because now it's only connected to a single orchestrator, right? So in this particular setup, when the broadcaster only has one option, sometimes you will see this, and that just means the transcoder is not keeping up with the transcoding jobs. And the other thing, I think another thing to know is that these transcoding these segments that are transcoding aren't all going to be paying out winning tickets. So as I am, as the broadcaster is sending the probabilistic micropayment tickets to the orchestrator for each segment, at some point the orchestrator will get a winning ticket, and the orchestrator will then go on chain to claim that winning ticket, and that's when the orchestrator would get paid in ETH. So oftentimes it takes 10 minutes up to an hour, depending on your transcoding parameter, to start seeing ETH coming in from the broadcaster, from the orchestrator perspective.
All right, so I see we're at the top of the hour here. Thank you very much for the presentation, Adam and Eric and Nico and Yandin, everyone who participated in. I think there's a lot of great, very useful content here. So the recording will be useful to the whole community. And thanks everyone for joining. Like I said, I know probably live peer infrastructure is not the top thing on most people's minds these days with everything going on. So stay safe, stay healthy. Live peers here, you know where to find us when you do have time to pay attention to live peer ecosystem. Yeah, hope everyone is doing well and keeps trucking. We'll see you later for the next call.
See you guys.
Thanks, everybody.
Awesome. Thanks, guys.
Thank you. Bye.
All right.